So today's lesson is going to talk about independent and dependent events in relation to compound probability. So to define independent events, the occurrence of one event does not affect the probability that the other will occur. We dealt with several of these on our homework last night, that rolling number cubes and flipping coins, even spinning spinners with equally likely outcomes, didn't change. If you have the probability of rolling a 6 and you roll the number cube once, the next time you roll the number cube you have the same probability. It doesn't affect the outcome or the probability of the second event. Weather predicting, we know that is a lot of probabilities, and there's a lot of things that weigh in and the factors there. However, whatever the weather is today will not affect the outcome of what the weather will be tomorrow. It's based on a lot of other things, but it is solely independent of what today's weather is. Just because it rained today doesn't mean it will rain tomorrow, unless conditions are right. Events with replacement. So if I'm drawing numbers out of a hat, and I put the numbers back in before I draw it again, the total outcome has been unchanged, okay? So those are independent, meaning that every time I do it, as long as I'm replacing it, I haven't changed the total outcome. Does anybody need more time for getting these down? Okay. For dependent events, the occurrence of one event does affect the probability that the other will occur. So compound events without replacement, so such as you have a jar full of marbles and you draw one out but don't put it back. The next time you draw, the total number in the jar has changed, right? So that second probability won't just be a theoretical probability, it'll be a probability given the first event already happened. And we'll be doing both of those and trying to distinguish between the two and to determine if two events are independent of each other or dependent on each other. So the probability of independent events happening can be written, just using letters, as the probability of events A and B being equal to the probability that A occurred times the probability that B occurred. So we did that last night, spinning a spinner and rolling a number cube, without any other requirements saying that, what is the probability of spinning a 2 and then, spinning a 4, that kind of thing. Event B was not dependent on what happened in event A. So we can use multiplication just like we did last night. And a lot of it goes back to the theoretical probability, just based on the total number of outcomes and the favorable outcome compared to the total. In example 1, we've got a couple scenarios. So if in A, probability of A is equal to 2/5, right? 2 out of 5. We don't even know what it is. This is just literally numbers. But the probability of B is 3/5. So the probability of A and B is simply multiplication. 2/5 times 3/5, which equals 6/25. And always reduce if you can. In B, the probability of A is equal to 1 out of 5. Probability of B is equal to 3 out of 5. Now these are the easy ones, right? Because I'm giving you what the probabilities are. I'm not even giving you the scenario. We just use multiplication. Actually, that's not what I wanted to do. What I wanted to do was say, oops, what's the probability of A if the probability of both is 3 out of 25? So we might have to find a missing factor, right? So that we know that the probability of A times the probability of B will equal the probability of A and B. So now we have one of those complex fractions, because to solve this, we'll take the probability of both and we'll divide it by the probability of the one that we know. And now we can get that. When you do this, remember you take the first one, 3 over 25, and then times it by the reciprocal of the second, times 5 over 3, so that we can get 1 over 5 as our answer. So we might have to find a missing probability just using that multiplication formula. Let's take a look at the probability of dependent events. The wording's a little bit different here, so that's really the only thing we have to get used to. So the probability of A and B happening is usually the probability of A times the probability of B given A has already occurred. This is what I'm talking about with replacement. So we write down that basic formula, and then using that multiplication property we can find a missing probability if needed. In the first one, A, probability of A is equal to 3/4. Again, I've already given you the probability of B given A, so just multiplication is going to give us the answer of the probability of A and B. So taking 3/4 times 1/2 will give us 3 over 8 in simplified form. You can cross cancel before you multiply. For B, everybody try to do this one. Okay, we're missing the probability of B, but we know that the probability of A and B together is equal to 8 over 25. So 8 over 25 divided by 4 over 5 is equal to probability of B. When we divide this, we will get 2/5 as the missing probability. Okay. All right. In example 3, we need to look at this, and it says tell whether the events are independent or dependent and find the probability. So now we need to know, because they're both going to be multiplication. That we do know. But in determining, are we using, if they're independent, we go back to theoretical probability. If they're dependent, then we have to kind of do a little bit of thinking and figure out what's the case for the second probability. The first probability will basically be theoretical. The second probability might have a changed outcome. So A, you randomly choose a green marble from a jar of 8 green and 3 blue. You replace the marble and randomly choose another green marble. So in this case, we can determine that it is independent because of the replacement. It does not change or alter the second probability. Let's try this again. A few more letters there. Independent. And the probability of getting a green marble, there are 8 green out of a total of 11 marbles. And when we replace it, there are still 8 green out of 11, so 64 over 121, and there is nothing to reduce. The second part, I have to choose somebody to give a report, and then randomly choose the person next to you from the 22 remaining students. This is going to be, because there are only 22 remaining students, we have to know how many people were in the class to start with. Yes. So this is dependent because once you have gone, you're not going to go again. So probability of A is 1 over 23. Probability of B is now 1 out of the 22 remaining students. So that the combined probability of A given B is 1 out of 506.